Special right triangles. Our objectives in this lesson is to be able to find the side lengths of special right triangles. These are right triangles whose acute angles measure 45 degrees and 45 degrees, or 30 degrees and 60 degrees. Let's start by examples where we use the Pythagorean theorem to find the missing side length. Now, these problems are probably not written in your notes, so just sit back and watch and try to soak in what's going on. Now, we have a right triangle here where two legs are congruent. So if this is 3, then the other leg is also 3. And to find the length of the hypotenuse, remember the side that's across from the right angle that we usually call C, we're going to use our Pythagorean theorem. C squared equals A squared plus B squared. The legs are the A and the B, so C squared equals 3 squared plus 3 squared. So C squared equals 9 plus 9. C squared equals 18, and then of course to get the squared to go away, we take the square root of both sides. Now we know that usually we would do plus or minus the square root, but because this is a side length, the negative doesn't make sense. The square root of 18 is equivalent to square root of 9 times 2, and the square root of 9 is 3. So the hypotenuse, simplified, is 3 times the square root of 2. Now notice that the two legs say 3 and the hypotenuse says 3 times the square root of 2. This will always happen when we have an isosceles right triangle because we have two legs that are the same. So we square both of those. We have 2 of the exact same number, hence the 2 that's left over because we have 2 of these numbers. So we'll always have the 2 left over in the radical. Instead of having to use Pythagorean theorem every time we encounter a right triangle that is isosceles, we can simply remember the shortcut that the two legs are the same and the hypotenuse is that leg number times the square root of 2. Now, if the two legs are the same, that means that the two angles also have to be congruent, and because they have to be 90 degrees, splitting them evenly makes 45 degrees each. So that takes us to our first of the special right triangles, which is the isosceles right triangle or the 45-45-90 triangle. Here's a reminder of the relationships between the sides and angles. The angles are 45 and 45 degrees, the acute angles, because there's the right angle for the 90 degrees. And the sides, if we reduce them down to 1, will be 1 and 1 for the leg and square root of 2 for the hypotenuse. Let's take a look at using these shortcuts instead of having to do Pythagorean theorem. Examples: find the missing side lengths for each triangle. In number 1, we have more specific directions. Find the diagonal of the square. This segment right here is the diagonal of the square, so that's the length that we're missing. Notice that it is also the hypotenuse of this right triangle. So by our finding that missing side length for the right triangle, we will have found the diagonal of the square. Now, because this is an isosceles right triangle, we know that these angles are 45 degrees and 45 degrees, and therefore we can use our special right triangle shortcut that each of these are 1 and the hypotenuse is square root of 2. So we simply take what the leg is and multiply by square root of 2. Therefore, the diagonal length is 5 times the square root of 2. Isn't that easy? If you can remember these shortcuts, you're going to save yourself a lot of time. Let's look at the second example. We have a 90 degree and a 45 degree. Therefore, the missing angle must also be 45 degrees, which means our two legs must be congruent. So this side has to be 3 square roots of 2, since this leg was 3 square roots of 2. We remember that the relationship between the sides is these are the same, and square root of 2 for the hypotenuse. So I take what was on one of the legs, and I multiply by square root of 2. Now I don't need to leave it like that because I can simplify here. The square root of 2 times the square root of 2 is just 2. So this is equivalent to 3 times 2, which equals 6. So while this is a shortcut, sometimes there is a little bit of simplifying to be done, but it is a lot faster than Pythagorean theorem. In number 3, we have a 45 and a 90-degree angle. Therefore, of course, this is 45 degrees, and these legs are congruent, which means what we have is the hypotenuse this time and not one of the legs. Let's remind ourselves that the relationship between the sides is the legs 1 and the hypotenuse square root of 2. This time, we're going backwards from the hypotenuse to get to a leg. So to go backwards, we have to undo multiplying by square root of 2, which means we're going to divide by square root of 2. Dividing by square root of 2 is easy in this case because it just divides out the square root of 2 that was already there, and we're left with 12 for the leg, and of course because the legs are congruent, that would be both of the legs. In number 4, again notice we have an isosceles right triangle, so our 45, 45, 90 triangle, and so we can remind ourselves that the shortcut is the legs are 1 and the hypotenuse square root of 2. So again, we have the hypotenuse just like we did here. So to go backwards to the legs, we think, how do we go backwards? We take our hypotenuse and we divide by square root of 2. Now, this time, I don't have a square root of 2 to cancel out from the numerator or to divide out from the numerator, but I can simplify this still by rationalizing the denominator. Here's what that means. I don't want a square root in the denominator, so I'm going to multiply by square root of 2 in the numerator and the denominator. Notice when I multiply by the same thing, I'm really multiplying by 1. Square root of 2 divided by square root of 2 equals 1. That's allowed. So I'm going to multiply square root of 2 times square root of 2 in the denominator makes just 2. So this equals 18 times square root of 2 in the numerator over 2 in the denominator. Now, of course, I see that the 2 can go into the 18 9 times. So this equals 9 square roots of 2. So each of my legs are 9 square roots of 2. So much easier than Pythagorean theorem. So let's memorize and learn and practice these shortcuts. Thanks for watching.